Hello everyone. We are now going to go over the flow plots from a bone marrow aspirate from a 47-year-old man who had 23% bone marrow blasts that showed cytoplasmic plebs. So, as usual, we'll start with CD45 versus site scatter. And the population that is painted red has the brightest CD45 and has low site scatter. And these are consistent with lymphocytes. And the population in orange here, they have bright CD45 and slightly higher site scatter than lymphocytes, and these are your monocytes. Population painted in green have dimmer CD45 than lymphocytes and monocytes and have very high site scatter. And these are the granulocytes in different stages of maturation, and they have very high site scatter due to their increased granularity. And we have a lot of cells here sitting in the blast gate, and they are painted in two different colors. One is the dark blue and the other is the maroon. So let's go to our table listing all the population and their percentages to see what they have labeled this as. So they listed the blue cells as progenitors. So progenitors or blasts, like, and because these cells are sitting in the blast gate, and then the maroon population is a subpopulation of these cells in the blast gate, and the blue cells account for 12.7% or almost 13% of all cells, and these maroon population, which accounts for less than 1%, it's actually 0.39%. They say that these are 34 and 117 positive. So this is a small population, and the majority of the cells that are sitting in the blast are those that are painted blue. So now let's further go over these plots. And we have CD34 versus site scatter here. Again, that shows these maroon cells are positive for CD34, but the cells that are painted in blue that are sitting in the blast gate are negative for CD34. So this is a bone marrow specimen. So you have to remember that bone marrows normally will have some myeloblasts, like in this case, the normal myeloblasts usually account for less than 1%, and like here they are only 0.39%. So these could be just background normal myeloblasts, but we don't know. Let's keep looking, but that's a possibility. Our cells of interest are probably going to be this blue population. So let's first look at these maroon population and get them out of our way. So they are positive for CD38. They're positive for CD34. So if you remember normal myeloid maturation, they start initially as being just CD34 positive, then they acquire CD38 positivity, and they lose CD34. So this is kind of going like this, which is normal. And they're negative for CD56, they're negative for CD15. CD15 is positive in granulocytes normally, so that's what we are seeing here. Our maroon population is negative for CD71. So these cells that are painted in pink, these are the nucleated red cells you can see here in the table in RBCs. They have the brightest CD71. Our blasts have CD71 similar to the granulocytes. So this CD71 here is very noisy, so it looks like it's kind of positive, but you have to compare with the normal control here, which are the nucleated red cells. So they are considered negative here. The blasts are considered negative. The blasts are HLA-DR positive, like you see in normal blasts, they're negative for CD123. So here you see a distinct population that is positive for CD123, which could be either basophils or PDCs. We need the HLA-DR to distinguish the two. In this one, they are buried deep inside, so I cannot really determine. But the table says that they are PDCs. So let's classify them as PDCs. And our blasts are negative for CD7, and they're positive for 117. So these are having the phenotype of a normal myeloid blast. Now let's go to the blue population. The blue population is sitting in the blast gate, but they're negative for CD34. They have partial CD38. They're negative for CD56, negative for CD15. They have maybe a dim CD71. They are partially positive for HLA-DR, negative for 123. They are negative for CD7. We can compare that again with the normal lymphocytes in the background, which are positive. So you can see how the intensity is in those cells. The blasts do not reach that intensity, so it's negative. And 117 again is a little bit noisy. So it's considered negative here. So in this tube, the blue population is only partially positive for CD38 and HLA-DR. Lineage-specific markers like 117, the myeloid lineage-specific markers are negative in this tube. So let's go to tube 2 to see if that gives us an answer. Again, in tube 2, your lymphocytes are here, the red population, monocytes here, the orange population. This tube also has markers like CD13, 11B, CD16. So this tube can differentiate between immature granulocytes and the mature neutrophils. So here the mature neutrophils are painted in fluorescent green. You see it here. And the immature granulocytes are painted in dark green, which are here. They both have high site scatter. And then again, in the blast gate, we have a population that is dark blue and maroon. So we see here the dark blue are our blasts of interest, which are 14% in this tube, and sorry, 12% in this tube. And the CD34 positive normal background blasts are less than 1% or 0.44% here. Once again, let's track the maroon population first. So the maroon population is positive for CD34. They're negative for CD11B, and they show that inverted C-shaped curve, just like normal myeloid blasts do. So normal myeloid blasts initially start as CD34 positive and negative for CD13. They slowly acquire CD13 and they lose CD34, and then they merge on to become the promyelocytes, which is the green population here. And these promyelocytes are negative for CD34 and they have bright CD13. So that inverted C is normal. So these are normal myeloid blasts in the background. Similar inverted C-shaped curve can be seen for CD33. So again, this is normal. And these are negative for CD14. So the bright CD14 population here are the monocytes, and which are also brightly positive for CD64. Your blasts are negative, and the blasts are positive for HLA-DR, they're negative for CD10. So nothing apparent in the maroon population. So they are consistent with the normal background myeloid blasts. Now coming to our blue population, these are negative for CD34, negative for 11B, negative for 13. They have a partial dim CD33 expression. They don't express CD14 or 64. We again saw in the last tube that they have partial HLA-DR, which is reproduced here. These are also negative for CD10. So now in this tube, we only have a partial dim CD33 expression. Again, CD33 expression is often associated with myeloid blasts, but they're not specific. The only marker that is specific for myeloid blasts are MPO, and 117 can be sometimes a great help. But markers like 13 and 33, they can also be positive in other lineages like lymphoid lineage blasts or megakaryocytic blasts. So they are not lineage specific. So now let's move on to the other two tubes. So going by the markers in these tubes, this is a B cell tube which has 19, 10, and 20. And this is a T cell tube which has CD4, 8, 3, 5, 2, and 10. So in the B cell tube, the blasts are painted as dark blue, and those are negative for 19 and 10 and 20. So again, nothing lineage specific for B cells. And in the T cell tube, these are painted black, and they're negative for CD4 and 8, negative for surface CD3 and CD5, negative for CD2. So again, nothing that hints towards T cell lineage. We already saw in tube 1 that they are negative for CD7 also. So initially, whenever you get a case of an acute leukemia or increased blast, all labs set up those basic tubes that are myeloid tubes, B and T tubes, and they also call it as screen tubes. So when most cases are straightforward and you get your answer in the screen tubes itself, like the blasts would restrict themselves to a particular lineage and you can easily identify them in the screen tubes. But there are cases when the screen tubes fail to indicate which lineage these blasts belong to, and then you have to go do additional work where you add on additional tubes with more lineage markers, like for example, erythroid blasts or megakaryocytic blasts. Because those are very rare, we don't usually include those markers in our screen tubes, but whenever our screen tubes fail to give an answer, we add those tubes. So if we see tube 5 has markers CD71, glycophorin, and CD61. So CD71 and glycophorin are erythroid markers, and CD61 is a megakaryocytic lineage marker. So in this tube, we can see that our blasts, again here's dim CD45 and low side scatter. These, again, there are two populations. One is the blue one, which accounts for 14% of all cells, and the CD34 positive, which is 4%. But that's okay because we should not use these flow cytometry numbers for our final estimation of blast count. But we already know that the CD34 positive blasts are normal marrow normal marrow myeloid blasts. So let's focus on the dark blue population. So the dark blue population, we already saw in the previous tubes that they have dim CD71 expression. So that is again seen here. They are negative for glycophorin. So here, the erythroid cells, which are CD45 negative, normal erythroid precursors, they lose CD45 as they mature. So we see them here. And those are glycophorin positive also. But our blasts are not expressing glycophorin. So we can kind of say that they don't express the erythroid markers. And in CD61 tube, we see that our blasts do express CD61. So CD61 is a megakaryocyte marker, and our blasts are expressing megakaryocytic marker CD61. So now tube 6 has more megakaryocytic markers, tube CD41 and 42B. So here, if you see, the cells that have low side scatter and dim CD45 are here. And we have, again, the CD34 positive cells, and the cells of our interest are painted in green here. So these green blasts are positive for CD41 here. You can compare that with the maroon cells, which are negative for CD41, which are our normal background myeloid cells, myeloid blasts. And then they also express a dim CD42B. So our blasts of interest express CD61, CD41, and CD42B. So these are all markers specific for megakaryocytic lineage. So basically what we have is a acute myeloid leukemia with megakaryocytic differentiation. So if you remember, the history also says that the blast shows cytoplasmic blebs. So that is another clue that erythroid and megakaryocytic blasts can often show those cytoplasmic blebs, especially megakaryocytic blasts. So this final diagnosis on this case turned out to be acute megakaryoblastic leukemia. But when we report it, we only could say that we could not call it directly from the flow cytometer because our blast percentage was less than 20%. Although we don't have to, we don't use the blast percentage from flow cytometry to we don't use that percentage as the final number. We always use the differential count, but sometimes, there are cases where you get like 80% blast, 70% blast. So those cases you can straightforward call it as acute leukemia. Here you cannot. So we just report it as 12% blast with megakaryocytic differentiation identified. Now, if you recall this, the blast in this case also had a dim CD33. So CD13 and CD33, and sometimes even a dim CD7 can be seen in megakaryocytic blast. That doesn't change anything. And CD71 is usually positive in megakaryocytic blast, but they don't reach the intensity of that you see in the erythroid blast. And CD34 and HLA-DR are usually negative, although in this case HLA-DR is partially positive, and CD45 is much dimmer in megakaryocytic blast. And actually, there will be cases where you can actually have them to be completely negative also. So one thing you have to remember is that sometimes platelets can go and stick on to other blasts. Like, for example, they can go sit on myeloblasts or lymphoblasts. And when you do flow, they can mimic a megakaryoblast, like being positive for 41 and 61, because platelets are positive for those markers as well, right? But to avoid that, sometimes some labs use cytoplasmic 41 and 61 to just get the more specific positivity only on the megakaryoblast. So you can do that. Other clues can be like they will be positive for all the myeloid lineage markers, and then the intensity of 42B and the other platelet markers would be very bright on those cells. So that can give you a clue that this is just platelets sticking on to the blast and not really a megakaryoblast. Thank you.